Hello, my name is King Tao, and this is me doing a presentation on firewalls. Firewalls, a part of the computer system or network that is designed to block unauthorized access while permitting outward communications. The concept of firewalls was not only started by a single person, but a collection of efforts of many security experts, including Jeff Mughal, Paul Vixen, Brian Reed, Willem Chepstick, Stephen Bolian, David Prisetto, Marcus Runum, David Pensnick, Nur Zirk, Fred Alvilio, and Brent Chapman. And first, I will now begin with the history of firewalls by explaining the process or the certain firewalls made during that time. 1988, the firewall predecessors. In the latter years of the 80s, the only form of protection that networks had at the time was network routers serving as initial forms of network separation. The devices themselves maintained basic isolations, ensuring any issues or protocols did not cross from one side of the network to the other. The idea of segmentation is further developed into the concept of firewalls. AT&T Bell Laboratories played a crucial role in the history of firewalls by developing the first circuit-level gateway around 1989 to 1990, a concept that laid the important groundwork for the next generations of firewalls. Over time, this concept continued to be expanded and integrated into the broader firewall technology. Circuit-level gateways. Gateways that monitor TCP handshake and other network protocol sessions initiating messages across the networks such as network as they establish between local and remote hosts to determine whether the session being integrated is legitimate. The advantages of it is the process requests transactions. The only process requested transactions, all other traffic is rejected. Easy to set up and manage. Low cost and minimal impact on end user experience. Disadvantages: offers no protections against the data leakages from other devices within a firewall on its own. No application, no application layer monitoring, and requires ongoing updates to keep the rules current. To keep rules current. 2000s, the start of stateful. During this time, it was the start of the concept behind stateful and stateless firewalls. As the picture shows, this is stateful versus stateless firewalls. Stateful tracks ongoing connections, understand traffic context, remembers previous interactions, detect patterns for security, manage complex traffic types, ideal for dynamic networks, and provided details across control. Stateless firewalls can be referred to the last slide, as well as all these things that goes with it. Stateful firewalls, as the type of firewalls started to show up, beginning a significant development in with firewalls. Stateful firewalls is based on the concept that not all packets are independent entities, that are in, that many are part of a larger conversation between hosts. Stateful firewalls not only examine each packet but also keep track of whether or not the packet of an established TCP or other network sessions. The advantages of it is that monitors the entire sessions for the current state of the current connection, while also checking the IP address and payloads for more thorough security. Offers a high degree of control over what content is let in or out of the network. Does not need to open numerous ports to allow traffic in or out. Delivers substantive logging capabilities. Disadvantages is that it's resource intensive and interferes with the speed of network communications. More expensive than previous firewalls options. And doesn't provide authentication capabilities to validate traffic sources that are fake and malicious. 2000s, Unified Threat Management, or UTM. Concurrent with the development of stateful firewalls, there was also the development of application firewalls. With the increased need for application-level securities due to the rise of sophisticated web-based attacks, vendors enhanced stateful firewalls with additional features to analyze and filter traffic based on application data. This created the Unified Threat Management, UTMs. UTMs combine the traditional firewall capabilities with gateway antivirus, intrusion detection, spam filtering, and other cohesive platforms, and not only allowed or denied traffic based on the state, but also on content, thus significantly improving security measures. Here again is a diagram that explains how a UTM works. Again, they implement VPNs, firewalls, quality of service, or bandwidth management, email, anti-spamming stuff, IPS, web security, routing capabilities. This is mostly used for businesses since vendors are in increased need of these type of services. Application level gateway. Devices that functions as proxies and sometimes refers to as proxy firewalls and is the only entry point and exit point from the network. Filtered packets not only filters packets not only to according to the service of which they are intended, but also by other characteristics, such as HTTP request string. Advantages of it are includes examines all communications between outside sources and devices behind the firewall, checking not just the address ports, but the TCP header information, but the content itself before it lets any traffic pass through the proxy. Provides fine-grained security control and protects user anonymity. Disadvantage can really inhibit network performances. Again, more costlier than the firewall options from before, and requires a high degree of effort to derive the maximum benefit from the gateway, and does not work with all network protocols. 2008 was the beginning of the third generation firewalls. In 2008, Palo Alto Networks delivered the industry's first next generation firewall, or NGFW. This introduced integrated intrusion prevention system, or IPS, full stack visibility, and ability to enforce security policies based on applications, users, and content. This was needed by 2008 as applications were increasingly using standard web ports to bypass traditional firewalls, making it difficult to control unwanted or potentially malicious traffic. So firewalls were no longer merely filtering ports and IP addresses, but they were also capable of deeper inspections to make informed decisions about what traffic can pass through a network. Next generation firewalls. In addition to the whole dimensions of firewall policies, enabling to block malicious content and support policies around data transmissions, NGFWs quickly became the norm, making it so network securities became capable of performing deeper inspections and making real-time security decisions based on the comprehensive data. The advantage of it is that it combines DPI with malware filtering and other controls to provide an optimal level of filtering. Traffics all Tracks all traffic from layer 2 and application layer for more accurate insights than other methods. Can automatically update to provide current context. Disadvantages is that to derive from the biggest benefits, organizations needs to integrate new NGFWs with other security systems, which can be a complex process and time consuming. And again, costlier as the firewall develops. 2020 was the start of fourth generation firewalls, or at least in recent news. In 2020, Palo Alto Networks introduced the first ML-powered next generation firewall. This uses machine learning to deliver proactive, real-time, and inline zero-day protection. Going beyond traditional threat detection by applying machine learning to analyze network traffic patterns and identify anomalies that integrate new types of cyber attacks. This provides a dynamic defense mechanism that adapts to evolving threats without relying solely on known threat signatures. Four mechanisms of the ML-powered NGFW. One of the mechanisms of it is inline machine learning, or ML algorithms. ML algorithms are enabled in the firewall code, meaning that the firewall can inspect files while it's being downloaded and block it instantly if it is malicious, without having to access offline tools. Zero delay signature. The ML-powered NGFW re-architects the way signatures are delivered. Signature updates are performed and streamed to the firewall within seconds after the ML analysis is done. ML-powered visibility accessed across IoT devices. The NGFW automatically loops similar devices such as cameras and tablets using ML-based classifications, tracking and preventing unusual and harmful activities. Automated intelligence policy recommendation. The ML-powered NGFW compares metadata from millions of IoT devices to and on the network to establish normal pattern behaviors. For each IoT devices and categories, the ML-powered NGFW then recommends a policy of the allowable behaviors. And here are the current firewall delivery methods, as in wanting to install or use firewalls. First one is hardware-based. Applications that act as a secure gateway between devices inside network parameters and those outside of it. As self-contained appliances, hardware-based firewalls don't consume processing powers or other resources of the host device. Ideal for medium and large organizations looking to protect many devices, but requires more knowledge and tech to configure and manage. Software-based firewalls. A software-based firewall or host firewall runs on a server or other devices. Needs to be installed in each device requiring protection and consumes some of the host device's CPU or RAM resources. Provided individual devices significant protection Provides individual devices significant protection against viruses and other malicious content. They discern different programs running on a host while filtering online traffic. On a fine-grained level of control, it is possible to enable communications to and from one program, but preventing it from to and from another. Cloud host-based firewalls. Managed security service providers, or MSSPs, offers cloud-based firewalls. This host service is configured to track both internal network activity and third-party on-demand environments. With firewalls as a service, cloud-based firewalls can be entirely managed by the MMSP, a good option for large and highly distributed enterprises with gaps in security resources, while also being beneficial to smaller organizations with limited staff and expertise. And here would I be presenting a demo. Let me just the demo that I'm going to be presenting is actually an online web application that has been called the Web App Firewall Simulator by Patrick Merchant. It is a process made entirely in a web browser that can simulate the actions between a firewall and outsiders. And right now, I'll be following the simple steps of configuring and how a firewall would react when comparing to event. So following the instructions below, I'll be doing something similar like this. By typing ipconfig in both of them, I can show you the IP address set by these two. The right side is the insiders, which is again, say the host server, and outsider is anybody outside that's trying to connect or send, trying to get information from the insider. Now, by typing nmap, now the reason using port 80, by typing out this command, I can specifically check whether the port to this network is open. And since port 80 is a common way of most of the interactions, as an outsider, I can check to see if it's open. If it's open, I can pretty much send any kind of data through or commands through specifically to the insider router or a system to kind of take control of it. Now, on the IP side, what I can do, typing in this command, by doing this, I essentially just stopped this, set a rule for that table to drop that port from opening. So if I repeat the command from outsider, I can see that the IP port is closed. Now, this is how usually a firewall would go, is that if it detects whether or not something's accesses that's not recognized by an IP, it immediately closes it. But in this case, since I essentially just dropped this port as a whole, I can change the IP outsider to an entirely different one. Once again, following the instructions on the bottom. and again be entering the or probing the port. The port is still closed. Even with the change ID on the inside, I essentially just shut off that port completely. Now let me just clear both of these with the command. Now for the insiders, I can check the rules by doing this specific command. Oops, sorry. One of the rules is inputs anywhere and everywhere are dropped. Now, I can actually upload certain rules, but as of this demonstrations, there has been some kind of bugs with it. So most of it will simply just be, let me see if this works this time. Yep. So if you're wondering how that looks, essentially with this program, you can download rules to set up a file that you can kind of like write. And within the thesis provided by inserting certain commands, you can kind of preset it so you don't have to do it one by one at a time. So for example, I've set a certain IP to be like this certain IP to be Google. So once all those rules are set, I can set the IP of the outsider to Google. And since you read in the rules that port 80 and 22 are closed, if I do something like doing nmap to port 50 to insider, it is open. But if I do it to port 80, it is closed. But if I set my IP to something other the initial set and do the exact same command, oh, sorry, do. Um, it is open because we have set because we have set the rule to essentially deny this Google address, any other address can be accessed, and these two are technically close to this address. By changing the IP, we have essentially allowed this one to go through. So if further, this is just a very simplification of how a firewall can work. But if you kind of expand the rules by adding literally hundreds and hundreds of codes that only allowed certain IP addresses and um, rules to actually change it, this would simulate how a firewall will work and reject certain connections made by outside connections. So, presentation. Here are my sources done by by my these are my sources from the presentation, and that should be it. Again, thanks for watching my presentation, and I hope a good time, and I hope you learned something from this.